uh, concentration in United Kingdom, the limit of gaseous hydrocarbon in the vehicle exhaust gases is 200. Means maximum 200 parts per million of hydrocarbon is allowed to come out from the vehicle. Like that's a limit. What is the maximum volume of gaseous hydrocarbon allowed in 10 mole of exhaust gas? So we have the formula, the concentration in ppm. So the concentration in parts per million or ppm is equals to moles of solute or amount of it's amount of hydrocarbon divided by amount of exhaust gases multiplied by 1 million. So the concentration in ppm is 200. Amount of hydrocarbon, so amount of hydrocarbon which is present, we don't know, x unknown. Amount of gases, its mole is given, so 10 mole multiplied by 1 million. So 10 will be multiplied, one exponent will be divided. So it will be 200 multiplied by 10 divided by 10 exponent 6. So what we get 0.002 moles of hydrocarbon. But in the question, we don't need moles. In the question, we need volume. So to convert moles into volume, we'll multiply by molar volume, which is 24. So volume of a gas in dm cube equal to mole multiplied by molar volume, which is 24. So when you multiply, it will be 0.048 decimeter cube. But then we have to convert into centimeter cube because all the answers are in cm cube. So we'll multiply by 1000. So if I multiply by 1000, I will get 48 as an answer. Is it clear? Okay, 2000 grams of a solution. (2000 grams of a solution contains 0.015 gram of solute. In the solution, the concentration of a solute in parts per million is, so how you can find the formula for concentration in ppm? Is equals to amount of solute divided by amount of solvent or amount of mixture this amount can be moles, this amount can be volume, this amount can be mass as well. Multiplied by 1 million. So we need a concentration in ppm. So amount of substance or amount of solute in a mixture 0.015. amount of mixture 2000 multiplied by 1 million, so 10 exponent 6. So if we have 0.015 divided by 2000 multiplied by 1 million. So what will be the answer? 7.5. So B is the correct answer. Another example. What is the concentration in mole per dm cube if you have 10.6 gram of sodium carbonate in 200 cm cube of solution? So the formula, concentration is equals to moles divided by volume and dm cube. So first we have to convert this 10.6 gram into moles. What is the formula for sodium carbonate? It is Na2CO3. So sodium is 23 multiplied by 2. Carbon is 12 plus oxygen is 16 times 3. So this is 46 plus 12 plus 48. So 48 plus 12, 60, 60 plus 46, 106. So the total mass is equals to 106. So we need the moles first. So 10.6 divided by 106. So moles equal mass in gram divided by molar mass. So 10.6 divided by 106. So we get 0.1 mole. So we have the moles and the volume is in cm cube. So we have to convert into dm cube divided by 1000. So 0.1 divided by 0.25. So we get the concentration 0.4 mole per dm cube. A solution contains 33 ppm solute. The mass of a solute dissolved in 1 kilogram, but all the answers are in grams. So 1 kilogram or mass of a mixture should be in gram, which is 1000. So you got the moles. You will use the formula concentration in ppm is equals to moles or amount of a substance or mass of solute divided by mass of a mixture. Mass of a mixture is 1000 multiplied by 1 million and the concentration is 33. So in this concentration in ppm, I'll substitute 33. So 33 multiplied by 1000 because in gram divided by 1 million, which will be 0.03 grams. Is it clear, these questions which relate the mass or volume to concentration? Any doubt in this? Okay, in the next question, calculate the number of atoms in 1 mole of hydrogen peroxide. So how many atoms, if we have 1 mole of hydrogen peroxide, it will give 6 exponent 23 molecules of hydrogen peroxide. because 1 mole of any substance will have 6 exponent 23 or Avogadro's number. So that is the number of the molecule. But in the question, we need atoms. So one molecule contain how many atoms? So because it is H2O2, one molecule contain 2 hydrogen atoms and 2 oxygen atoms. So what is the ratio between molecule and atom? 1:4 is the ratio because 2 hydrogen and 2 oxygen. So one molecule contain 4 atoms. So if we have 6 exponent 23 molecules, how many atoms will be there? X cross multiply. So 6 multiplied by 4, 24. So this will be 24 exponent 23. Or, but they, if you convert point, take move another side. So it will be 2.4 exponent 24. Is it clear? So D is the right answer. Is it clear? The concept, how we can identify from molecule, how we can identify the number of the particles. Any doubt in this? Some questions I want you to solve. I will share this after completing a topic so that you can solve the questions because it is related to acids as well. So definition of relative atomic mass, mass of an atom of an element relative to 1/12 mass of carbon 12, mass of atom relative to mass of hydrogen, average mass of an element relative to 1/12 mass of a carbon atom, or average mass of an atom of an element relative to 1/12 mass of a carbon. So average mass of an element basically is not necessary because element can be molecule, element can be it can be molecular atomic, so it's just an element. Average mass of an element, as we discussed earlier, the definition. If you check the first part, so relative atomic mass is average mass of one atom compared with the 12th part of mass of one atom of carbon 12. Here, when it is atom is there, like one atom, then mass of one atom of carbon 12. But in the options, when you check, so average mass of an atom of an element relative to 1/12 mass of atom of carbon 12. So both ways we have to use this term because this is a standard definition. That's why atom is used here. Okay, next question. The Avogadro's constant is 6 exponent 23. Number of atoms in 1 mole of carbon dioxide. So how many atoms are there in 1 mole of carbon dioxide? If we have 1 mole of carbon dioxide, it contains 6 exponent 23 molecules. And what is the relation between carbon dioxide molecule with the atoms? It contains 1 carbon atom and it contains 2 oxygen atoms. So the ratio between one molecule to atom is 1:3. So if we have 6 exponent 23 molecules, how many atoms will be there? X. Cross multiply. So when you multiply this, 6 multiplied by 3, 18 exponent 23 or 1.8 exponent 24 will be the answer. Is it clear? Sometime the percentage is given and we have to find the concentration in parts per million. Look in the question. The concentration of a carbon monoxide in exhaust gases without a catalytical converter is 0.7% by volume. In units of part per million, the concentration is, so how we can do or how we can solve this? So basically, the formula for concentration in ppm is a mass or amount of solute. So here, carbon monoxide is there, divided by exhaust gas. And that is multiplied by 1 million. So we are finding, but this value is given in percentage, which is 0.7%, because they mentioned carbon monoxide to exhaust gas is 0.7%. So if it is 0.7%, how to convert percentage into fraction? So to convert percentage into fraction, what I will do, I will divide by 100. So what it will make 0.7 divided by 100 into 1 million. So these two zeros will cancel with the zeros. We are left with 4 zeros. So when we multiply, so it will become 1, 2, 3, 4. So it will become 7,000. Is it clear? Because in this, the percentage by volume is given 0.7%. So this value, carbon monoxide divided by exhaust gases, this volume ratio is given 0.7%. So we convert this 0.7% into fraction by dividing with 100 and then multiplied by 1 million. So we got the final answer. Any doubt in this? So tomorrow I will continue, means next class I will continue this modes and acid topic. I will share this file with you, but you cannot solve all the questions right now. Only specific questions, the topic which we studied or discussed today, moles and concentration in parts per million. Only those questions you will solve and leave the rest or remaining questions. Any question related to today's class? Any question? Okay, so I'll end the session and share the recording.